Good morning one and all. In today's lecture, we will see how to solve the numerical on the SFD and BMD. Okay, in the previous lecture, we have seen the theory part of the SFD and BMD. Okay, here is a one numerical is given. Okay, simply supported beam is given. Okay. On that simply supported beam, you have given the UDL load. UDL means uniformly distributed load. This load is uniformly distributed the beam. Okay, and the value is given W kilonewton per meter. Okay, and length of that beam is given L. Then how to draw the SF and BMD? Or how to do the SF calculations and BM calculations. In today's lecture, we will see the details. First, you have to remember the first step is that you have to calculate the support reaction. Okay, which is the support reaction? There is one more. There are two supports. One is the RA and second is the B support. Then we can say here is the support reaction RA and support reaction RB is there. Support reaction RA and support reaction RB is there. Then how to calculate? You know what is the definition of the SFD? Okay, you have to do the vertical summation of vertical unbalanced forces. Okay, it is the vertical unbalanced forces. Here is a two forces only. Okay, I will write here first sign convention. If you vertical the left of the section, then you have to consider the vertical as a positive. Then see RA is going upward direction. That's why we are consider the positive. Since it is the summation of the reaction RA plus RB, because both are going upward direction. And there is one more force is applied, UDL force at on the beam, W is there. Okay, and how to convert that W into point load? Force into distance is there. And where is that? At the CG. What is the CG? If you convert this figure, then see you will get here RA and here is a RB. Okay, this will add as a point load W into L at the CG of that figure. Means L by 2 from the left hand and right hand at the center. Okay, all of you getting? If you have given the UDL, then you have to convert it to the point load or keep as it is. Okay, and how much load is act on this beam? W into L. And which direction? In downward direction. Means here is a minus W into L is equal to 0. Okay, I will write here summation of Fy. Okay, vertical forces is equal to 0. Then you will get the first equation, RA plus RB is equal to what? W into L is there. But we have the two unknown. We want to calculate any one value. Then you have to take the moment above the section at a point A or at a point B, any one point. I will take summation of MA is equal to 0 at a point. You have to consider clockwise positive. Okay, we have seen the sagging and hogging also. If the left side of the section, this movement is going clockwise direction, then we are consider the positive. Then see here this we are consider A is 0. Summation of MA is equal to 0. Then this one check that we are going right to left. This is going clockwise direction. If you have considered the section after the point load, check that this is going clockwise direction. Okay, how much force is applied? W into L is there. Into distance. What is movement? Force into distance. Force is W into L into L by 2. Okay. Then check that this force is going anti-clockwise direction. That's why you have to consider the negative. Means RB minus RB into total distance up to the A point. Into total distance up to the A point. Total distance is given. Total length is equal to 0. Then you will get the RB into L is equal to what? WL square divided by 2. Means RB is equal to what? RB is equal to what? You will get this side then WL by 2 is there. WL by 2 is there. Okay, this is the value. When you putting this value in this equation, then you will get again RA is equal to WL by 2 is there. Okay, or when you given the symmetric figure, then remember that this support reaction is equal to total load divided by 2. Total load divided by 2. How much total load is given on this beam? Check that, WL, and divided by 2 means you will get the WL by 2. WL by 2. First step, all of you getting? First you have to find the support reaction. Then second, once you have find out the support reaction, then you have to draw the SFD. This one is the WL by 2 and this is also same value WL by 2. Then we will draw the SF calculations. Okay, SF calculations. Let the SF at A point, change that SF at A point, just left side. This left side of that A is equal to, you will get the 0. SF at A, just right side. If you have taken the just right side coming, then you will get the RA value. What is the RA value? WL by 2. WL by 2. Okay. Then SF at next point, which is the next point? B point is there. Just left side of the B. Check that. We have the RA value WL by 2. Because this is in upward direction. That's why positive. And one more value in between that, A to B, minus WL by 2, minus WL by minus WL. Okay, minus WL is there. If you have calculated this, then you will get what? You will get the minus WL by 2 is there. Minus WL by 2 is there. Okay. And SF at A, B, just right side, you will get the 0. Check that. You have to calculate that value with the help of calculations. SF at A, 0. Okay, A point is here and B point is here. First point, left point, 0. Then second point, SF at right side is equal to WL by 2. We are going upward direction because we have the positive value. WL by 2 is there. Here I will mark WL by 2 is there. Okay. Then SF at B, just left side, check that, minus WL by 2. This just left side here is just left side, minus WL by 2, downward direction. Because below the 0 line you will get the minus WL by 2. That's why we are coming downward direction. Then you have to join these 2 points. How to join? If you have given the UDL in the loading diagram, then remember that you have to draw the inclined line in the SFD. Okay, draw with the help of inclined line. This I will show you that point. Okay, this is your SF. This one positive, this one negative. Okay, all of you getting how to do the SF calculations. Once you have calculated SF or drawing SFD diagram, then after that BM calculations. We will see the BM calculations. Check that bending moment at A point is equal to also 0. You start from the 0. Bending moment at point is equal to 0. And second point, again bending moment at B point is equal to 0. Means always the first point and last point you will get the bending moment always 0. Bending moment at A point 0, and bending moment at B point also you will get the 0. Then how to draw the SF? Here, if you are getting the inclined line, then here you will get the parabolic curve. Remember that. Then if you have drawn the straight line, then this will be wrong. This will be wrong. That's why we want to calculate maximum bending moment. Maximum bending moment. And where we will get that maximum bending moment? Where the shear force is 0. Check that is the shear force diagram. Where is shear force is 0? Here is shear force is 0. But we don't know the distance from the point A from the point B also. You have to find out first the distance. Okay. Then how to calculate that distance? You have to take the summation of SF. Okay. Suppose here I will consider this section is a XX. This section is a XX. Okay. And we will consider this distance is a x from the A point. Then you have to calculate the value of x. You have to calculate the value of x. And I will write here summation of fx sf at point xx is equal to, check that there is a vertical load WL by 2. Only consider the loads. Okay, don't consider the movement when you find the sf WL by 2. Then check that is there any other load is that here is a UDL is that UDL is a W is there, means W into X, W into X. Okay, again in which direction? Downward direction. Minus W into X is equal to 0. Right? Summation of Xx at point, we will calculate the section Xx is equal to 0. Then you will get the WL by 2 is equal to W into X. And X is equal to, you will get the L by 2. X is equal to L by 2. Very simple. You can calculate this X value with the help of taking the moment about that, shear force at XX is equal to 0. Then you will get the X is equal to L by 2. Once you have got this X is equal to L by 2, then we know that where is the shear force is 0, there we will get the maximum bending moment. Okay, at L by 2 point we will get the maximum bending moment. It's at the center. At the center. Okay, then how to calculate this value? How to calculate this value? Maximum bending moment. I will calculate here maximum bending moment BM max. Okay. At the section XX again. How to calculate maximum bending moment at the section again XX? Here we will get the maximum bending moment, right? At the section XX. Then check that at the section XX, this RA up to this, you have to consider only this figure. Okay, you have to consider A to this point only. Okay, RA is going clockwise direction. That's why WL by 2 into this distance up to this XX section. This is the L by 2. Means I will write here WL by 2 into L by 2 into L by 2. Right? Then see, is there any load in between that A to this point? Okay, up to the center XX section. Yes, here is a UDL is at. UDL is at. Okay, how much UDL is that? W into L by 2 again. W into L by 2 again. Up to the distance XX minus, because if this load is going here, we will consider this WL. Here is a W into L by 2 is that. Okay, where is that? At the CG of that distance A to XX. A to XX is half of that. Here you will get the L by 4 distance. Okay, this is going anti-clockwise direction. That's why minus W into L by 2 minus W L by 2. Okay, into this distance up to the X. This distance is a L by 4. L by 4 is equal to 0. Okay, maximum bending moment at XX we have considered the 0. And check that WL square by what? 4 is there minus WL square by 8 is there is equal to 0. You can take the LCM, then you will get the this one maximum bending moment at X section is equal to, you will get the W by 8 is there. Okay, you have taken the LCM, then you will get that value is W L by 8 is there, W L square, sorry, square is there, W L square by 8 is there. Means you will get the positive value. Okay, and this equation is a parabolic equation. If you have calculate in the form of x, then you will get the second degree of equation. Here is the L square is there. Okay, that's why you have to draw, when you draw the inclined line in the SFD, then you have to draw the parabolic curve in the second degree parabolic curve in the BMD. Remember that. I will join with the help of parabolic curve. Okay, here is a 0. Also first and last point, check that you will get the 0. Always you will get the 0. But what is the maximum bending moment? Here is a WL square by 8 is there. And this bending moment will get the positive. This is the BMD and this is the SFD. Okay, all of you getting? Very simple. You have to remember the sign conventions. What is the sagging? What is the hogging? Okay, you have to remember any one, left of the section or right of the section. If you have starting from the right side, then again you will get the same answer. You will get the same answer. But here is a more important, when you calculate, doing the calculation of the BMD, then remember that here if you are getting at the point A 0 and B point is 0. But here you have drawn the inclined line with the SFD. Then here definitely you will get the parabolic curve. So you have to calculate the maximum bending moment. And where will get the maximum bending moment? At the where shear force is 0. And where is shear force is 0? At the center. Then you have to calculate this distance with the help of SF at the section XX. Okay, this you will get the L by 2. And after that, take the again movement about the section XX. Bending moment about the section XX. Okay, you will get the maximum bending moment, and this maximum moment is WL square by